Welcome everyone to these tutorials on how to build self-driving car simulator. Uh, we will learn how to get familiar with Unreal Game Engine and also how to use C++ for Unreal Game Engine. In addition, since we are talking about self-driving cars, that means we are talking about deep learning, reinforcement learning, and computer vision. And for that, we need Python also, and we will learn how to connect Python with Unreal Game Engine. And again, talking about deep learning, there are different frameworks, but TensorFlow and Keras what we'll be using here. In addition to that, we have OpenCV for some computer vision tests. We also will cover classical control systems such as PID controllers and how to do robotics motion planning. Before starting deep into the development of the simulator, I would like to show you some introduction about self-driving cars and the level of automations. So in self-driving cars industry, we have mainly 4 to 5 levels, starting from level 0 with no automation at all, so the driver has a full control of the vehicle. Level 1 is basically about the automation of one driving task. For example, the cruise control, the automatic braking, or the automatic steering. So I'm saying here or, that means because we have only one task. So either cruise control or speed, for example, control or automatic braking or automatic steering. When it comes to and, which means we are automating multiple tasks together, then here we are talking about level 2 automation, like adaptive cruise control with lane keeping, for example, and automatic braking and so on. So we have multiple tasks that are actually automated by the AI system there. Now, level 3 is basically as level 2, but in addition to that, we have also automated perception, which means that the car can detect events, can detect other vehicles, can detect traffic signs or traffic lights as well. So this is basically not only about the control, but also about the perception and the motion planning. Level 3, though, we still have the driver, and the driver can interrupt the system in any time, especially in case of emergencies, and can take control of the vehicle. So we still have the steering wheel within the car. Level 4 is automation without the need to the human driver anymore. That means we don't have steering wheel at all. And the car is doing all the tasks automatically, but it can only operate under certain conditions and in certain environments. For example, we do have now level 4 buses, and these buses can drive only along specific path and also, for example, with optimum conditions, for example, without heavy snow or maybe with light day only. So we do have constraints about the environment, and this is level 4. Level 5 is full automation. That means the car can drive, for example, on highways, inside cities, with bad heavy weather, with good heavy weather, and so on. So it's any condition without any constraint and without the need to drivers. So let us get started. Before start using Unreal, we need to install it, of course. And in order to install it, you need to go to epicgames.com and then create an account if you don't have an account there. Then install the Epic Game Editor from here. So I will assume that you have it already installed. So when you open the Epic Game Launcher, you would actually get into this home page. What we need to do first is to install the game engine, Unreal Game Engine. The Epic Game Launcher basically contains the game engine, but also the library and store, for example, for buying some pre-created environments or pre-created games if you want to adapt them or edit them for your game, for example. we would not use them at this moment. And what we actually care about is the Unreal Engine itself. So if you are here under mainly library, you would see under my project is basically the project that you have already created. And here some packages or add-ons or assets that you already bought or installed. But what we need first actually is to add an engine version. So if you don't have, you need to click here to add your engine version. I think the last one is basically 4.24, but I prefer now to start with 4.23.1 because the Python package, the current Python package currently only works with 4.23. So if you have that installed, please press over launch. So it would take a few minutes, or actually less than a minute. So we have here the Unreal Project Browser now, and we will start with a new project. You can see that we have two type of projects in Unreal. We have the Blueprint and we have the C++. Uh, I prefer to start with C++ project because here we are doing more like, as I said, robotics, and we would need to do some coding with C++ and Python. So in any way, actually, if you start with C++ project, you can also use the Blueprint that also like graphical programming for Unreal Game Engine. So I'll start with C++. I want to select, let's say, predefined project or template. And here I will select the vehicle advanced. The reason we are selecting this project because the car there is already built, the environment is already built. We will adopt the environment, but what is important here is the car model that is already designed. So I'll start with the vehicle advanced, as I said, maximum quality. It's better with starter content, for example, and just here we need to give the project name. So here I'll just call it self-driving, for example, simulator 1. I have already one. Yeah, click, so create project. So you can see, first of all, we have here now the Xcode editor or ID is already opened, and we have here the project directory. We have the engine and the games. I'll talk about them later. So because we choose C++ based project, so you would always see the ID of C++ code, which here in Mac Xcode would open, and Windows most probably with Visual Studio would open when you select C++ project. So this is the environment that we have selected, or the template. We can directly test it. So if I click here play, we see that we have a vehicle that we can actually control with your mouse click. I was with your keyboard, sorry. So we have the arrows on your keyboard, or you can use WSDA. And you can see this is predefined environment. We have some roads there that we can use. So this vehicle, the physical body of this vehicle and the dynamical model of this vehicle is already developed and designed for this template. So we don't need to care about that. What we see here, basically, the gears and the speed in kilometer per hour. These are now important for our first project, especially the speed. 2 to 3 sessions, what we will be doing actually, we will be building level 1 self-driving car. And we will start by automating only now the speed limit, which means the kind of the cruise control. In order to do that, first we need to adopt this environment. So we assume that we have only straight road, which means because we're only automating the speed, so we are not now automating the steering, for example. So we need to have a straight path, let's say. So for that, I need to adjust this environment or to edit it. And to do that, we would learn something new, which is how to use speed lines to build roads. So first of all, I want to delete what we already have, and it's better if I move to the top view. If you double click over your vehicle here, basically you would directly be taken to the vehicle position, and that will zoom in basically at your main vehicle, which is actually the pawn here, the main player. So as I said, what we want to do now is basically we need to delete what we have already. We need to build kind of straight path. This is basically what we have here is also not enough. It's kind of short path, so I want to extend the working space here. First of all, what we see basically here, we have what is called the blocking volumes. From their name, we can know that they block our working space, so the car cannot actually go through that blocking volume. So if I drive here, now it will actually crash, or it will end at the blocking volume, as you see. So I need to move this blocking volume to the right, because as I said, I need to extend the working space. So now I'm moving it right. Once from here it would be enough. We have a kind of illumination volume, so I also want to scale it up. So I want to scale it along the X axis. So let's have it till here. This one also kind of protection volume. We can also scale it along the X axis. So on. And now we need to add basically rod, let's say a straight rod from the position of the car here until the end of our working space, so until the blocking volume. So because it is straight line, but this straight line could have some curves, as you will see later. So that's why it's better to use spline, because using spline we can actually automate the creation or the design of the roads. So what I want actually to, again, go back to the vehicle here, select the perspective view, and let's create a new folder. We call it Blueprints. And here we need to create a new character as a Blueprint class. So we have basically actor, pawn, and character. I would actually select actor because actor is an object that is a static object in the environment, and rod is a static object. Pawn is basically a moving object that is controlled by the user or getting input from the user. Character is a moving object, but actually it has its own movement, so it doesn't receive input from the controller. So I would select here the actor. I would call it the rod spline. Double click here the rod spline, we would see basically the blueprint window. And here we have the viewport, the construction script, and the event graph. So the viewport is basically the 3D environment of your actor, or the actor that we added. We need to add a mesh, or actually we need to add a 3D object for that actor. And here what we have first is what we need to add first is this line, because it's our reference here. And the spline starts with 2 points, as you see here. So we have the first point and the second point as they are connecting by a link. If you are familiar with lines in Photoshop or Illustrator, basically they have the same concept. So each point here inside this line basically has a tangent, and if we move that tangent, basically we change the curve at that point. So because we are changing the tangent vector here, we can add as many points as we want, and we can create curves, as I said, with this spline. So what I want to do also, I want actually to now create static mesh which represent road brick, and this road brick would be deformed along that spline. So we need to go to the construction script. The construction script is like the constructor in a C++ class, so which means it will be called the construction of that class or the construction of our object here. And here now I need to, or first let's get our spline object here. So we need to get that. So we need to get the number of points for that spline. So get spline actually get number of spline points. So the target is actually the spline that we have created. Now we need to for loop from 0 to the number of points -2. I'll just let you know why -2. So first we need to select for loop. Starting from 0, we have here basically integer add, and now we need to actually subtract 2. And that basically means starting from 0 and end at the number of points -2. So why -2? First of all, so we need to, at each point here, we need to add mesh. We need to add a static mesh that we need to deform. And for example, if we have now only 2 points in that spline, so our position would be here. We need only to add mesh there. So that basically means -1 because we are here, and also -2 because considering the indexing here in the blueprint, basically that is start from 0 to 2. And actually I want to add the mesh at 0. So that's why, for example, 0 -2, then we'll have here only 1 point. If we have a 3 point, for example, it would start 0 and it would add here 1, and the second one would be added there at the index 1. So what we need to do now at every step in that loop is to add spline static mesh, or actually mesh components. And our mesh here, as I said, is the road brick that we have there. So I'll select maybe the straight half. Okay, so that means that every point that would be added, we need also to add in which direction we would deform that mesh. So we need to do set forward axis. So we need to deform that object in the direction of the x-axis. And that should be like this, right? So now we need to tell Unreal from which point to which point we need to deform that object. So as I said, the object would start, we have already seen actually that the object would start at the first point, and we need to tell Unreal to deform that object until the end of that point. For example, here, as you see, when I extend or increase the distance between these 2 points, this object is not deformed yet. And now what I want to tell Unreal, basically, when I extend the distance between these 2 points, then this object should be extended, should be deformed to fill that link between these 2 points. So for that, basically what we need to do now to get now the location of this point. So we need to get the location of the first point and the location of the end point. And we need to extend or deform that mesh from the starting point to the ending point. For that, we basically what is called is set start start end. So set start and end, and for that we see that first of all, what is the target? So what we are deforming. So actually we are deforming that mesh, which is the brick. That should be executed at every step in that loop. We have starting position, starting tangent, the tangent vector, ending position, and ending vector. So what is our starting position? We actually need to get spline point position or get point. So it should be location. Yeah. So it is get location at this prime point, and we need also to get tangent at this prime point. So our target is actually again that in our spline here. The index now of the first point, we can actually get it from the index here in the for loop. And we need now the index and tangent at the next point, because as I said, we need to deform from the first point to the next point, and then so on. So for that, we actually also need again to add here, and we take the index of that point, then we add 1. And now we need to do the same for the ending point. So I need to copy or duplicate these 2. Again, we have here, and now we have the new index. Now I just need to actually now connect the location of the starting point, the tangent and the starting point, and now the location at the ending point, and also the tangent and the ending point. Now, if you compile and save, hopefully everything's fine. If we look at the viewport, now we see that actually the object was deformed. So if I move that, now the brick is following this spline. If I actually do now that, we see also the same. So now the brick here, the road brick actually now has a backbone, let's say, or has a skeleton, and this skeleton is this spline. So let's use it now. So after we create its constructor, so actually now I can add this spline to scene there. Let's put it in front of the car. And we can select here the quad view. If we double click our vehicle, we can see now we have, for example, top right back view. I would like to hide the landscape just to also the lightning. No, the lighting is not an issue, but the landscape, yeah. So this is our object here. So if we can see it there. So it has 2 points. We can now actually take that point here, the second point, and then extend that road as you see. So I want to have, if we zoom out, so for, let's say, the first quarter of the road that should be straight. Then I want to have small climbing, so I want actually to add now a new point at the right view there. And this is now our ending point. So if you right click here, we can see that we can duplicate this spline point. So if I click here, I have now a new point. So just place this point right after the first point, because we need now to, let's say, fix the tangent at this position, and again duplicate that point. And now we can create kind of slope, as you see, like here. So let's make it high slope. Then duplicate again that position, and let's let the car move straight. Then again, let me see how much space do we still have. Okay, we still have quite good space. So then now let's duplicate and create. So you see, basically we have this curve, which doesn't look, or it's fine, or doesn't look that natural, let's say. So it's better if you face that. Is basically, as I said, to create first a point just right after the first point, then we duplicate again, then we can have it like that. So again, duplicate, and now we can have straight again until the end. So let's save and go back to the full view, perspective view, and now press play. Now we can see that we have straight line in the beginning, or straight path, and now whoop, you can see that we actually went under the road or the bridge there. That's because our spline, or actually our static mesh there, doesn't have yet a physical object. And as you see, also we can actually here drive over the side here. So we need to add a physical mesh to that road or to that static mesh. Physical body, or actually we need to add what is called collision to that static mesh, which is the road here. So let's click, or let's open again our spline or road spline blueprint. And if we select here the add spline mesh component under construction script, we can see here basically that under collision we have here, so default there's no collision, and we need to add collision. So we have overlap that would let the object to overlap with the static mesh, which we don't want that. Actually, we need to have the block all collision. We need to save and close now. And if I press play, we can see that actually we have a kind of physical object that this car cannot overlap, or actually cannot overlap or go through. I want to do one thing. Actually, I want to make this slope, or actually I want to increase the distance of that slope, or the length of that slope. So let's no, not from here. So this is our spline. Okay. I have moved the wrong point here, so let's select. Okay, that should be fine. Because I want to test now once we build the speed automation or speed limiter, we want to check if the car or the AI or the controller that we build will keep up the speed even when the car is climbing high. Okay. So now it looks better. All right, so for the first step, which is, as I said, making controller that would control the speed limit, this environment now is enough for us. So the last thing in this video, in this session, that we need to do is to show the speed error. Because the first task, as I said, that we want to automate is the cruise control or the speed control. And for that, we have what is called the target speed. Let's say our target speed is 30 kilometer per hour, and we want to calculate the error there, which means the difference between the actual car speed and the target speed. We want to visualize that in basically in our scene, and mainly in here at the main display of the user, just to have it as a reference later to see how the controller is performing. So to do that, we need to now move to the C++ code. And I just want to note this one. So this is basically our C++ code. As I said at the beginning, we have the engine folder, which actually Unreal is an open source. So it's here the source code of the engine itself. We don't need to touch that. If you go under games, it is our project, and then select source. Then here our project again folder. Now what the display of the user, what's called here HUD, is under this HUD object, and we have the pawn here, which is the car, or actually the main player object. So if we check first the source code of the HUD, here we see that we have two. We have the speed and the gear, and we see that in the display. We need to add, as I said, the error. The speed, for example, here is just creating a speed text item. So it is a text that we will draw on the screen or display. And it has a position, but also it has a value. And this value is actually coming from vehicle. So what is vehicle? Vehicle is an instance of our pawn here, which is the main player, which is the vehicle, the car. And this vehicle has let's say here, a variable. It's called speed display string. And this vehicle, as I said, is an instance of the pawn, and the pawn is actually what we see there. So first of all, we need to create a new variable that is called the error display. So if we go to the header of that pawn and we go here to the public, we can see that we have the speed display string and the gear display string, and we need to add another one, as I said, and we need to call it, let's say, speed error. Now, if you're not familiar with Unreal Game Engine, this U property means that we can see that variable in the blueprint editor. This is the category. So under which category, I'll show you that later, but let's put that as control, because this is what we will use to control the vehicle. And here, that means we can only read that variable, so we cannot edit it from the blueprint or inside the blueprint editor. So it is in public, so it's because we can access it from other objects. And now let's actually check where the speed display is changed or is edited. So we actually, if we search for it, we see that we have a function that is inside that the pawn class. This function is called update the HUD settings, and the first variable here defined is actually the speed, which is a kilometer per hour. We can see that we get the movement of that vehicle, and we can get the forward speed of that vehicle, and this is our kilometer per hour. We have here just a transformation of where we convert that kilometer per hour to integer number, and this is the gear. What we need to define here now, our target speed. So it is target kilometer per hour. Let's say it's as I said 30 as a float. Then we have the error. So let's say we have the error QPH here. That is equal to the difference between the target, and the actual speed. We need to have an integer version of that again. So now we need to update the public variable or public string that we have actually initialized here. So it is the speed error display. It is an f text. This is an Unreal text object, and we need actually to put here the error instead of the kilometer per hour. So this is how we actually update that string there. Now we need to move again to the HUD object, and we need to add now new text to display. Let's call it here the error speed. We need to change the name here again, so it is we have the error or the speed error. text. What we are inserting out the value actually is not the split display string, but let's get it from here. It is a speed error display. Let's have a red color because it's representing an error. Then we have this one should be there, and we need to draw it. That should be fine now. So if we move back to our game editor, so I need now to compile the C++ code. So because they have the same Y positions, let's put it 545, save, and again compile. Okay, so that's strange. Okay, probably it was not saved. Okay, so now we see now the error there. And of course, at the beginning, the error is 30 kilometers per hour because we have 0 there. And if I increase my speed, the error would be decreased and we can get a negative error. So that is perfect for us now because we will use that later for the controller. And for that, I would conclude now this session. And then in the next session, I will give an introduction about control systems, mainly PID controllers. And we'll see how we can integrate these controllers in Unreal Game Engine and use them to control the speed limits of that vehicle. Thank you very much.